Okay, so we're going to do another method of sections, and I want to find DE, DJ, DK, and JI by method of sections. And we had talked about that with method of sections you could only find 3 unknowns, and I have 1, 2, 3, 4. So I'm going to take this hint and list all of my zero force members because that might get rid of one of my unknowns. I'm going to start at the left. Okay, if I look here, I have 5 kips coming down. I've got to be 5 kips pushing up. There's nothing in the X direction. 0. Perpendicular, perpendicular, perpendicular. It's not quite perpendicular. I'm going to have this over here. So that would be my zero force members from the get-go. I also need to look that if I look to the left of my cut, I'll need to have this reaction at G. If I look to the right of my cut, I'll need to have this reaction here at K. So either way, I'm going to have to find reactions. So step number 1 is a free body diagram and equilibrium to find reactions. So we're going to draw a picture overall. Kind of looks like a little spaceship there. And I have 3 kips. I have 10 kips. I have 5 kips. I have GY. I have GX. I have KY. This is 10 feet. This is 20 feet. This is 3 feet. So if we look at the right, I'm going to sum moments about G. They have to equal 0. Come straight through. So I have negative 3 kips times 3 feet minus 10 kips times 20 plus 10 is 30 feet plus KY times 20 feet equals 0. So I should find that KY equals 15.45 kips up. So if I look here, now if I sum forces in the Y direction, I'm going to have GY minus 5 minus 10 plus 15.45 kips up equals 0. So I'm actually going to find that GY is 0.45 kips going down. And you may stop and say, oh my gosh, it can't go down. Can it go down? Yes, it can. If I look at this system, I have a big part of loads over here that are pulling to cause a clockwise or clockwise rotation. And if they're pulling this way to cause a clockwise rotation, they're going to want to rotate around that roller. Okay, it's going to want to like rotate around the roller. So I might need this reaction over here to pull it down. So it's okay if you have reactions that are coming down. So now I'm going to come back up and I want to cut DE, DK, and IJ. And I'm just going to go ahead and draw those 3. That's a 0. So I can see my cut's going to have to somehow come through here. And I can either look at from the right, intention, 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 or from the left. Let's use a different color. Okay, intention, intention, intention. Okay, I either need to look from the right, everything intention pulling to the right, or from the left, everything intention pulling from the left towards the right. It doesn't matter which way you go. I'm just going to look at the right. So I can use my post-it note, kind of cover it up, and I should have then my free body diagram of my section. And this is where you could pause the video and draw it yourself and then check to see if you have the same answers that I do, or the same figure. So here's E, and I have 3 kips pulling over. Then I'm going to come down to M, where I have 10 kips pulling down. I'm going to come right back here to K, where I have 15.45 kips pushing up. And then I have E, D, so I have my force ED that's pulling towards that. And I have this member okay, KD, so I have that force in KD that's pulling up, and then I'm going to go through J, and I have a force JI, and it is pulling towards I. So this one is looking a little bit different because we have cut the way that we've cut it, but I know that the member that I had coming down was a zero force member, so I'm just not even going to include that. But I am going to do some labeling with my dimensions. So I have 5 feet, 5 feet, 5 feet, 5 feet. This is 3. When I look at this slant, I'm going to need to go back and find, well, what is the rise and run? So if I come back and look at this member right here, I can see that my run is 5. Make that bigger. My run is 5 and my rise is 3. So this is going to be 5 squared plus 3 squared, which is the square root of 25, plus 9, which equals the square root of 34. And I'm going to leave it as the square root of 34 so I don't start rounding too soon. I still need to get the batteries in here. 25, 9 plus 34. Okay. So I can come back down here, and I can show my rise is 3, my run is 5, and I have the square root of 34. And these are both in the x. So again, we're in the dilemma of I have 1, 2, 3 vectors, 3 unknowns that have an x component, an x component, and x component. I don't really want to start then with x component. I could go with summing. So this would give me 3 unknowns. I could sum forces in the y direction, and I could solve for KD. Okay? I could sum moments about this point right here, which is D. Get some moments about D. Goes away, and I could solve for IJ. Okay? I could sum moments about, where else could I sum moments about? I could sum moments about this point right here, about K. If I sum moments about K, I get rid of KD, and I get rid of IJ, and I could solve for ED. When I get any number of these, I could go back and use summing forces X, or I could just use summing forces X to make sure equilibrium holds true. So I could solve for KD, KJ, where did I solve for JI? Oh, IJ. So I could solve for these 3 using summing forces Y in moments, and then I could use this equation to make sure that our forces equal 0. So let's just start with summing forces in the y direction. So if I sum forces in the y direction, up is positive. Has a y component of 3 over root 34. So I have 3 over root 34 times KD. And then what else do I have in the y direction? Plus 15.45 kips. Okay, minus 10 kips equals 0. So 3 over root 34 KD equals negative 5.45. So KD equals negative 5.45. 5.45. 34 square root times 3 divided by, and I get 10.6. So KD equals 10.6 in compression. Okay? So I am weird, and I like to actually see it. I don't want to use a negative number showing it in that direction. I'm going to show it actually comes back in compression. And I have a value of 10.6. Okay, so now I can sum moments up here about D. Just cover that all up. Let's sum moments about D. The sum of the moments has to equal 0. That gets rid of ED. It gets rid of KD. It gets rid of these 3 kips, so I have minus 10 kips. Okay, times 5, 10, 15, plus 15.45 times 5, okay, minus ji times 3. So these are both going to be perpendicular distances in the x. This one's going to have that perpendicular distance in the y. This equals 0, so I have 3 ji equals positive 150 minus 15.45 times 5. And I get that ji equals, so I have 150, 15.45, 5 times, minus, divided by 3, positive 24.25 kips. It's positive, so it's indeed in tension. So I can come back down here, and I can note that this is 24.25 kips. It's in tension, it's correct. So now I've got check, check. So if I sum the moments about K, it gets rid of my reaction, it gets rid of Ji, it gets rid of KD, so I can solve for ED. So let's sum the moments about K equals 0, and I have 3 kips times 3, which is negative, plus 10 times 10, which is also negative, plus ED times 3 equals 0. Bring those over, I get 3ED equals 109, so ED has to equal 36.33 kips positive. It's in tension, so this is 36.33. So how can I check my work? Let's sum forces in the x direction. I'm going to have Ji, okay, Ji was in tension, so it's going to the left, 24.25. I am going to have, one of those should be in compression. Let's go back and look at this. Minus about D. Minus, plus, minus. There's a negative there. So when I bring this over, positive, negative, I still have a negative here, which means this is negative, which means this is in compression. And this is why it's so important to go back and check your work, because I was quickly going to find I wasn't going to be in equilibrium. And I was quickly going to find one of those needed to go back in compression, and it's this one. Okay, it's this one. No, Ji is on the bottom. Ignore that. Ji down here. This is in compression. So now when I'm summing my forces, if this is in compression, it's pushing back. So I have 24.25 negative plus 36.33 positive. Tension, compression, positive, negative, plus 3, okay? Then I have this member in compression, so it's going to the right. So plus 5 over square root of 34 times, this member was 10.6, and all of this should equal 0. So I have 24.25. That is the, okay, that is the compression member here on the bottom pushing this way at 24.25. Then I have 36.33 change signs. That is the tension member up here pulling to the left. Okay. Then I have a positive 3. Okay. And then this member is in compression, so it is going to the right. 5 over root 34 times, and its value was 10.6. So I have 24.25, negative 36.33, positive 3, 5, enter 34 square rooted, divided by 10.6 times, positive, plus, plus, plus. And I indeed get 0 equals 0. And so by doing that quick step, I realized that I had very sloppy algebra. And I was able to go back and correct my mistake not only here, but then I could verify that these two other values that I found for KD and ED were in fact valid, just by doing that quick check. Okay, if I hadn't done this quick check, I would have given you guys a wrong solution. Anyways, this shows you the importance of checking your math.